Hey, welcome to my webinar entitled Solve Your Struggling Software Project, Tips on How to Pull Out of a Nosedive. My name is Scott Dormel. I'm the CTO of Swiftcom, and I'm here to chat to you about practical things you can do if you are in a horrid software environment where all kinds of things are going wrong, right? So the first thing I believe that everybody who gives a talk should do is basically give you an indication of how long the talk's going to be. Because in case the talk sucks, at least you want to know how much longer the talk is going to suck. So there are only 10 slides in this presentation, so that gives you a general idea of when your out will be. We're going to discuss pulling out of bad software experiences from three different perspectives. The first one is basically if you have software that's getting out of a external contractor. Let me 1 second. The first one is if you have software being built by an external contractor. The second one is if you have software being built by an internal business unit. So in other words, in these first two scenarios, you're not necessarily directly in control of it. You're either the product owner or you're downstream of the software requirement. And the third one is basically like if either yourself or your team is building software and things are going wrong. So the first thing basically is to understand what's going wrong, right? The thing is basically that software, especially the larger the organization is, the more complex the system of building software becomes, and oftentimes it's sometimes unnecessarily complex. The thing to understand is essentially that what you are looking for, right, is you are looking for working pieces of software. So if you think of like a factory, for instance, and you think of requirements as the raw materials and working pieces of software as the end product coming out the other side of the factory, it's those working pieces of software that you're really interested in. Now that factory, to use that metaphor, essentially has a constraint. And there's this concept in systems theory that says every system has a constraining factor. And once the constraining factor is lifted, growth will continue until the next constraining factor is hit. So to give you an example, if you have an old VW Golf and you're riding on the highway and the thing can't go very fast, right? Basically, the constraining factor of your speed there is the power of your engine versus the weight of the entire vehicle. Right. And until you essentially like either remove weight or increase the power, you're not going to go any faster. Now, at a certain point, you might start going faster, but maybe the next limiting factor might be the speed limit of 120, for instance, if you obey the speed limit, of course. And similarly, like in any system that produces anything, certain resources within that system are the constraining factor. So there are people or there are processes internal to whatever is producing your software that is overloaded or misapplied in some way. Now, one of the interesting things is that the more complex a system is in terms of moving parts, the more inherent simplicity must fundamentally underlie it. Now, what do I mean by that? If you take the metaphor of like a jet, for instance, if you think of what a complex piece of machinery a modern jet is, it has in excess of 10,000 parts. If you take those parts and you pull them apart and you basically lay them out on the floor and you give yourself the mission to move them all in unison from one side of the country to the other side of the country, it'll actually be incredibly difficult to keep them all like relative to each other's location as you move them from one point to another. Even if you don't move them in the same relative manner and you just try to pack them again on the other side, you still have a fairly complicated system on your hands. However, the system as a whole, once all of those complicated parts are together, can basically be controlled by something like 6 different controls inside of the jet. And that allows the entire jet to move from one side of the country to the other side of the country, right? So even though at this point you might feel that your situation is somewhat helpless because it's too complicated, the fact of the matter is just that if the system has survived until this point, it probably has some fundamental simplicity underlying it that you can leverage to improve the system. Now, unfortunately, we can't really go into a massive amount of depth and examples of this. So further reading here, I would recommend you read the work of Eli Goldratt, specifically the book, The Goal. And another one I would recommend is It's Not Luck. Okay, so feedback loops and error rates. So any feedback loop in a system can immensely impede output of the system once the error rate in the system increases beyond a certain point. So essentially the concept here is just that if you have some resource that works on a work item, right? So remember that what you're interested in is you're interested in a working piece of software. If they work on a piece of software and they make a mistake, or there's something that can go wrong in them working on it, but then it has to go to somebody who tests it, and then it goes into live production. And only then is the mistake really picked up. The act of having to now basically tell the person again to basically loop back the piece of software to the person who was working on it and say, okay, well, now you've got to fix this, right? If any such relationship exists within your system, then essentially the error rate and the actual speed at which you can iterate, both of those metrics become unbelievably important, right? Okay, so essentially what you want to do in this case is you want to eliminate feedback loops that affect the system's constraint. So in other words, once you've identified what is sort of the bottleneck, let's say the bottleneck is a team of 3 people who have an enormous amount of outstanding work that they have to do, right, within your organization, for instance. Or you have an external contractor where you've given them a lot of work and, you're sort of not really getting joy out of them. You've got to sort of figure out roughly by intuition what exactly is the thing that's essentially ticking over the slowest. What you want to do there is you want to make sure that any sort of feedback loop in there and any sort of possible error that can negatively affect that constraint gets eliminated. So what do I mean by that? So if you, for instance, request a piece of software, make sure that your request is very small and is correct. Because if you make an error and you give it to something that's already overloaded, you're only going to pick that error up on the other side of it. And that essentially means you're going to basically take 2 units of time to essentially fix that thing. The simplest way to fix both your feedback loops and your error rate is to just reduce the size of what you request, right? So in other words, if you have either an internal business unit, you have a single developer, or you have an external contractor, make sure that your requests are as small as possible. The second thing is to have a definition of done. So a definition of done is something that you have to say, listen, when does this thing actually create business value for me? When does this piece of software do what I intended it to do? And then essentially to only have one piece of software go through the system at a time, right? So there are many ways to accomplish this. And again, due to time, we can't quite go into them, but I'll touch on a few different scenarios now on different contexts that one might be in. All right. So the first one is if you're working with external contractors, right? Now, there are many challenges with working with external contractors. Typically, people go onto a site like Upwork or some other freelancer website, and they typically go farm out for the cheapest people out there, right? And there are many, many challenges with that. Many of those people are incredibly professional, but still just in the dynamic of working with them, a lot of things can go wrong. One of the primary things I would say is to really work on your concept of your definition of done for yourself, right? So the first thing is basically is it live? In other words, is it actually in a state where it's creating value for the business? A piece of software that you requested, is it actually on your website? Is it in your application? Is it doing what it's supposed to be doing, right? Really in the real world out there. Not, oh, we tested it, and it's working on my machine. Working on my machine is not a definition of done, right? Then obviously, does it work? Does it actually act as intended? And then another thing would be does it break anything else? Does it have any externalities, right? You can refine this concept of a definition of done as you work. If you're working with external contractors and you already have, you already have a system, but it's fairly unstable, then what I would strongly recommend you do is that you primarily have them focus on sorting out the most critical bugs. Right. So in other words, figure out what bugs have the biggest negative impact on your business and order accordingly. Then essentially take those bugs and solve them one at a time until you are essentially convinced that you now have a stable product again. And then from that point on, you only request one thing at a time from your contractors, and essentially wait for them to push it all the way through to live. And then you put your energy into making sure that that process of requesting one thing and seeing it go live goes as quickly as possible. external contractors number 2. So the second thing here is like Eli Goldratt has a great quote where he says, "Tell me how you will measure me, and I will tell you how I will behave." So one of the first things here is essentially you should basically give. I'll really belabor this point throughout the rest of the thing as well. You should really give people very bite-sized things to do, and wait for those bite-sized things to be completed in totality. Right, that's the primary thing. Right, so now people know that they get rewarded for focus, so their behavior will be more focused. The second thing I would insist on is daily stand-up meetings. In a stand-up meeting, essentially, you only cover 3 things. You basically say, what did I do yesterday? What am I doing today? And am I stuck behind anything? Right. And you can use daily stand-ups in anything. You can use that in your family context. You can use that when people are building, extensions to your house. You can do all kinds of stuff here. It's really a powerful methodology to get to basically get continuous progress out of a situation, because things change on a daily level. It's not always possible to plan everything very far ahead of time. Yeah, and then basically, again, only focus on one discrete item at a time. Make sure that if you have external contractors, you have a very clear singular expectation of the one thing that they need to get done for you next. Whenever you're in a situation of there's like 50 things and you're waiting for them and they keep telling you that, no, it's going to get done, it's going to get done, you are in trouble, right? You need to prioritize those 50 things, take the top one and say, guys, this is all I want for now. Give me this thing, then you take the next thing, then you take the next thing. Right. So the next thing is basically if you have an internal team, right? So again, there are varying degrees of maturity for software development, and it always surprises me how even after a decade and a half of the Agile Manifesto being widely adopted, we still see like a lot of things, a lot of organizations not implementing this stuff. Since this is just a very, very high overview, I would basically say that if you have an internal team that you're not getting joy out of, one of the first things I would insist on is a ticketing system. So this doesn't have to be massively laborious. You can just use Jira or Trello. And essentially, again, the idea is that you make one small, well-defined piece of software, or one small, well-defined requirement on the ticket, which is basically like, as a user, I want to be able to change my password, for instance. You have very simple tickets like that, and you essentially push them through the system one by one. Your steps don't have to be too much. You typically have a backlog, which is like a set of all your outstanding tickets, and then you like have per period, which we call a sprint. You'll basically like select some of the tickets, and then essentially the developers will pull them through one by one and actually take them live. Again, you need a definition of done as well, and really like only one ticket at a time. And then the other big thing is like also finish tickets. Really finish a thing, like have it bug free, have it out, have it live. That's how you make progress. Internal team number 2. If you're doing Scrum, but everything still hurts. Okay, so essentially, it's also possible that you're already in a situation where your team is doing Scrum, but for some reason everything is still going wrong, right? And here I would basically look for short-term and long-term feedback loops. So essentially, maybe go look at things where certain work items where you believe some reason down the line, somewhere outside of your immediate experience, break down for some reason, and then eventually swing back. Now, that could mean that you have deployment issues. That could mean that there were actually before you, there were requirement issues that were incorrect, and now basically in the business actually like constantly cause all manner of drama, which then basically causes a feedback loop to you. Do you spend a lot of time per feature because you don't trust your technology? Another thing that could happen as well, basically, is, and lots of developers don't really think about this. It's not very frequent that developers question the quality of their tooling always. They'll blame their tooling, which is completely different from questioning the quality of your tooling, right? If you find yourself blaming, the stuff you work with, then, that's maybe a little bit of a character issue. But you can question the quality of the stuff that you build with. You rework a lot of stuff because the tech breaks in production and then comes back to you, right? So over the last couple of decades, basically, obviously JavaScript has become by far the most dominant programming language in the world. And JavaScript is unfortunately too dynamic and too permissive of a framework to really like, or well, of a language to really like allow you a lot of reliable ways to essentially build software that doesn't fall over, right? So what I would say there basically is that what you need to start doing is you need to start, if you can't affect complete system-wide change, you need to start finding ways to make incremental improvements. So essentially what I would say there is, again, start with things that make your system unstable. Identify the things that cause errors and the various feedback loops. See if you can eliminate a feedback loop. And the second thing would basically be see if you can, if you find something that's actually causing you a lot of what we call process variance, which is basically like, instead of the thing working the same way every time, it works a little bit differently almost every time. Find that stuff and then basically rank by what is causing the most pain and what is going to be the most effort to fix, right? So divide pain by effort, sort that list for yourself, and essentially start sorting out those things systematically one by one. Two very, very good books that were written on this by Gene Kim. The one was only written by Gene Kim. The other one was written by Gene Kim and collaborators, is the Unicorn Project and the Phoenix Project, which I strongly recommend everybody in IT, whether or not you actually program or even are involved directly in software project management, definitely read. Okay, so the next one is, what if it's just me, I'm all alone? The first thing I would say, like if it's just you, and I know there are many people unfortunately in this situation, is insist on only doing one thing at a time and finishing it, right? Don't tackle 50 different tickets at a time. Take one thing from your perspective, make sure that that one thing is completely ticked off, is perfectly wrapped, and is then basically like also taken live. If you are prone to distraction, I know I am, and unfortunately a lot of the other people I know am, what you might want to do is you might want to lock your phone in your car, and you might want to install rescue time for yourself so that you can actually like block distractions from your machine if you do struggle to focus on one thing at a time and actually get the one thing at a time out. In terms of just some practical stuff that'll actually, again, this is unbelievably brief because we basically have just over 20 minutes. One of the major things that I would say just to up your game as a software developer is to try the following concepts. It might feel very, very strange to you. These are all concepts that originated from the functional programming world. But they've obviously started to seep into all other paradigms of software development as well. The first thing is basically never reassign a value again, right? So in other words, or a variable. There are these two concepts. The one is a variable and the other one is a value. And the difference is basically that a value has a specific value and a variable has the value of a variable can vary, hence variable. So the first thing is stop using variables. The way that you would do that in most languages is typically through a const keyword, right? Start declaring everything as const. In other words, make sure that you never reassign anything. Now, you might ask yourself, well, how do I program then? Well, that's where it gets interesting. I would definitely encourage you to explore that rabbit hole. The next thing is basically to never write a loop again, right? So never write a while loop, never write a for loop, never write basically any kind of loop. And instead to embrace map, filter, and fold, right? So if you don't know what map, filter, and fold is, I strongly recommend that you Google those, but those are different ways of actually working with collections of data. Then another framework that I would extremely strongly recommend that you check out is there is a framework called reactive extensions. And reactive extensions, I think, exists for something like close on a dozen different environments. And that was also a paradigm that was very strongly influenced by functional programming. And you can actually take that and go and apply it in almost every environment. Right. And these are just like some very, very basic things. Like if you're having pain as a software developer because you're struggling with all kinds of bugs and problems and things, in my experience, these were things that immediately started to relieve a lot of this pain. And then basically, I just jokingly said at the end here, you can also enter Valhalla by learning Elm or F#. I really strongly recommend both of those languages. it's going to completely like shift your mind in terms of how software can work and how reliable software actually can be. And even if you are not as fortunate as we are to actually work in it on a day-to-day basis, you can still take many of those concepts and try to implement similar types of reliable methodologies, in your own work environment. All right, and I'm a man of my word. This is slide 10. Yeah, thank you for attending.